So the equation we just got for f prime of x, so it was f prime of x equals negative 2x minus 4, where f of x was this equation. Negative x squared minus 4x plus 1 is a function in terms of x. So the graph of x is pictured here. It is a parabola facing down, as you can tell from the equation. And so let's actually find f prime of x for negative 4. So remember, f prime of x is negative 2x minus 4. So if I want to find f prime of negative 4, then I can just plug in negative 4 for x. And so we have negative 8 minus 4. Oh, sorry, positive 8 minus 4, which is positive 4. Negative 2, f prime of negative 2 is negative 2 times negative 2 minus 4, which is 0, 4 minus 4. And negative 1, f prime of negative 1 is negative 2 times negative 1 minus 4, and so that gives us negative 2. So now what we're going to do is use a ruler, and we're going to draw a tangent line to the graph of f of x on the grid over here, and we're going to do that at x equals negative 4, x equals negative 2, and x equals negative 1. So at negative 4, go up to the graph and put a point where the y value is, and then we're going to draw a tangent line there. So I'm going to try, because you already know I'm not very good at drawing these lines, I'm going to try to put a line right there for my tangent line. Now this is a little wonky. It should just brush right up against your point. So something like that. And I'm going to make that a different color because I want to. Nope, that doesn't work. All right. There we go. Okay, so that's our tangent line at x equals negative 4. And then let's take a moment to just do that at the other points as well. So at negative 2, we're going to draw another tangent line. That one's a little bit easier to do. And I'm going to make it a little thicker. All right. And then let's do the same thing at x equals negative 1. So this point right here. So when you're doing this, you should be putting your ruler right up to the graph. And it should just be brushing right up against your point, like that. It's a little bit hard to get used to when you're first starting to draw them, but you'll get the hang of it. Oh, that's a little too big. Sorry, I'm being really particular about what these look like. All right, there we go. Again, if you weren't already, you should be using colored pens to help you along here. Okay, so let's think about what these tangent lines have in common with our derivative. So on the other side, we had talked about that the formula that we were using was the slope of the tangent line. So let's actually check the slopes of these tangent lines and see what they are. So if we look here, negative 4, what is the slope of that line? So hopefully if you drew your picture nicely enough, you can see that if you pick 2 points like maybe here and up here, your slope, you go up 4, right 1. So that slope is actually 4. Notice that matches up with our answer over here. If we look at x equals negative 2, you can see this slope is just 0. You can tell that the slope is 0 because it's a horizontal line. That's the definition of a horizontal line. It has no slope, so the y value doesn't change at all. And then for the last, so that does match up with our answer, by the way. And the last one at -1, we can see our slope, it goes down to right 1. And so that slope is -2, which again matches up with our answer. And so if we want to summarize what we just said there, we can say that f prime of x will give the slope of the tangent line at any value x. So if we want to find the slope of the tangent line at a particular x value, we can just plug it into the derivative. All right, so let's actually write out our equation that we've been using and kind of talk about it. This is going to be super important. This is something you definitely want to memorize. So maybe highlight this box. I'm going to highlight it for you. This is super important. I haven't even written anything yet, and I'm telling you it's super important. All right, back to my pen. So this is the definition of the derivative and what it represents graphically. So f prime of x, that's our derivative, is the limit as h approaches 0 of f of x plus h minus f of x all over h. And that represents the slope of the tangent line to the graph of f of x at any x value. So our derivative is the slope of the tangent line. So we're going to take it a step further, and we're going to find the equation of the tangent line. So in order to find the equation of a tangent line, you need the point and the slope. And we're going to use the point-slope formula. Y minus y1 equals m times x minus x1. x1, y1 is your point, and m is your slope. So our point at -4, you can look back up at your graph. The point is -4, +1. The slope we already found is +4. That was from our derivative. And so our equation is just going to be y minus y1, which in this case is 1, equals 4 times x minus -4, which will end up being +4. That is our tangent line equation. This is going to be a common question on the AP exam, and if it's free response, you can always leave it in point-slope form. That is where you want to stop. You don't need to solve for y. You don't need to put it in slope-intercept form. This is good enough. All right, so try the next two on your own. Pause the video. Really pause the video and try it out yourself. All right, so I'm working on the second one. Hopefully you actually try them out. Now this one I would actually try to solve. It simplifies nicely because of that 0, so we just get y equals 5. And the last one, our point is -1, 4. Our slope we said was -2. And so we get the equation y minus 4 equals -2 times x minus -1, so that's +1. And that is our tangent line equation.